Welcome friends and Namaste. Om Namah Shivaya, Jai Shri Ram, and today we will study class 10th science chapter number 4 carbon and its compounds. So let's start this chapter. So in the last chapter we came to know many compounds of importance, many compounds important to us. This chapter we shall study about some more interesting compounds and their properties. Also we will be learning about carbon, an element which is of immense significance to us both in its elemental form and its combined form. Okay, now so look at the items that come in the last column of the above table filled by you. So your teacher will be able to tell you that most of them are made up of compounds of carbon. Can you think of a method to test this? What would be the product if a compound containing carbon is burnt? Do you know any of tests to confirm this? So things made of metal, things made of clay and glass, others. Things made of metal, things made of glass and clay, and things made of other. So food, clothes, medicines, books, or many of the things that you listed are all based on the versatile elements of carbon. Food, clothes, medicines, books. In addition, all living structures are carbon based. The amount of carbon present in the Earth's crust and the atmosphere is about quite less. The Earth's crust has only 0.02% carbons in the form of minerals like carbonates, hydrogen carbonates, coal and petroleum. And the atmosphere has 0.03% of carbon dioxide. In spite of the small amount of carbon available in nature, the importance of carbon seems to be of immense. In this chapter, we will be studying about the properties of carbon which make carbon so important to us. Why the carbon is so important to us. Now, bonding in carbon, the covalent bond. So in the previous chapter, we have studied the properties of ionic compounds. We saw that ionic compounds have high melting and boiling points and conduct electricity in solution or in molten state. We also, just like we have ionic compounds NaCl that's ionic compound and that can conduct electricity in its solution or in its molten state. We saw how many nature of bonding in ionic compounds explain these properties. So how the nature of any compound is there and their properties. Let us now study the properties of some carbon compounds. Most carbon compounds are poor conductors of electricity, as we have seen in chapter 2. From the data given in table 4.1 on the boiling and melting points, carbon compounds, we find that these compounds have low melting and boiling points. These compounds have low melting and boiling points as compared to the ionic compounds. We can conclude that the forces of attraction between the molecules are not very strong. Since these carbon compounds are largely non-conductor of electricity, we can conclude that these bondings in these compounds does not give rise to any ions. In class 9th, we have learnt about the combining capacity of various elements and how it depends on the number of valence of electrons. Let us now look at the electronic configuration of carbon. The atomic number of carbon is 6. What would be the distribution of electron in various cells of carbon? How many valence electrons will carbon have? We know That reactivity of elements is explained as their tendency to attain a completely filled outer shell, that is, attain noble gas configuration. Elements forming ionic compounds achieve this by either gaining or losing electrons from the outermost shell. In the case of carbon, it has got 4 electrons. It has got 4 electrons in its outermost shell and needs to gain or lose 4 electrons to attain noble gas configuration. If it were to gain or lose electrons, 1, it could gain 4 electrons forming C4 negative anion, but it would be difficult for the nucleus with 6 protons to hold on to 10 electrons, that is 4 extra electrons. It could lose 4 electrons forming C4 positive anion cations, but it would require a large amount of energy to remove 4 electrons, leaving behind a carbon cations with 6 protons in its nucleus holding on to just 6 electrons. Carbon overcomes this problem by sharing its valence electrons with other atoms of carbon or with other atoms of other elements. Not just carbon, but many other elements form molecules by sharing electrons in this manner. The shared electrons belong to the outermost shell of both the atoms, lead to both atoms attaining the noble gas configuration. Before going on to compounds of carbons, let us look at some simple molecules formed by the sharing of valence electrons. The simplest molecule formed in this manner that is of hydrogen. As you learnt earlier, the atomic number of hydrogen is 1. Hence, hydrogen has 1 electron in its K cell and it requires 1 more electron to fill its K cell. So, 2 hydrogen atoms share the electron to form a molecule of S2. This allows each hydrogen atom to attain the electronic configuration of the nearest noble gas, that is helium. So, which has 2 electrons in its K shell. We can depict this using dot or cross to represent the valence electrons. The shared pair of electrons is said to constitute a single covalent bond between 2 hydrogen atoms. A single covalent bond is also represented by a line between the 2 atoms as shown in figure number 4.2. This is single dash line. The atomic number of chlorine is 17. What would be its electronic configuration and its valency? Chlorine forms a diatomic molecule Cl2. Can you draw the electronic configuration dot structure of this molecule? Now that only valence shell electron share needs to be depicted. Similarly like hydrogen. In the case of oxygen, we see the formation of double bond between 2 oxygen atoms. This is because an atom of oxygen has 6 electrons in its L cell. The atomic number of oxygen is 8 and it requires 2 more electrons to complete its octet. So each atom of oxygen shares 2 electrons with another atom of oxygen to give the structure of shown in the figure C here. The 2 electrons contributed by each oxygen atom give rise to the 2 shared pairs of electrons. This is said to constitute double bond between the 2 atoms. So this is double bond. So now we have learnt about single bond and double bond. Can you now depict a molecule of water showing the nature of bonding between the oxygen, one oxygen atom and 2 hydrogen atoms? Does the molecule have single bond or double bonds? What would happen in the case of diametric molecule of nitrogen? Nitrogen has atomic number 7. What would be its electronic configuration and its combining capacity? In order to attain an octet, each nitrogen atom is a molecule of nitrogen constitutes 3 electrons, giving rise to 3 shared pairs of electrons. 3 pairs shared of electrons. In S2O, there is S2O. This is said to consider triple bond between 2 atoms the electron dot structure N2 and its triple bond can be depicted in figure 4.4. So it's triple bond. In S2O, shared one by H and one by this H. Both shared each other and complete the configuration S2O. Convert the conjugation S2O. So this is a formula for a molecule of ammonia NS3. Now can you draw electron dot structure for the molecule showing how all 4 atoms give noble configuration? Will the molecule have the single bond, double bond or triple bond? Right? So in S2 it will single bond. In NS3 it will be single bond. Let us now take a look at the methane, which is compound of carbon. Methane is widely used as a fuel and it is major component of biogas in compressed natural gas. So methane in compressed natural gas. It is also one of the simplest compounds found by carbon. Methane is formula CH4. Hydrogen, as you know, has a valency of 1. Carbon is a tetravalent because it has only 4 valence electrons, right? In order to achieve noble gas conformation, carbon shares these electrons with 4 atoms of oxygen as shown in the. Such bonds which are formed by sharing an electron pair between 2 atoms are known as covalent bonds. Covalent bond molecules are seen to have strong bonds with the molecules, but intermolecular forces are weak. This gives rise to low melting and boiling points of these compounds. Since the electrons are shared between atoms and no charged particles are formed, such covalent compound bonds generally are poor conductor of electricity. So this is the electron dot structure of methane, that is CH4. And this carbon is sharing its extra element with the other ones. So this forms and this forms, and it becomes the electron dot structure of CH4. So I hope you understood about the carbon and its compounds introduction. And carbon has got positivity about C4 and C4 positive, C4 negative, right? It can lose either 4 elements or it can get other 4 elements. So, and how the different molecules and different atoms combine together, and what is single bond, what is double bond, and what is triple bond, right? So, and how the methane forms, how the 2 nitrogen atoms combines, how the 2 oxygen molecules combine, and how the 2 hydrogen atoms combines, and other elements of how the water and 2 chlorine atoms, 2 atoms of chlorine and ammonia. So now we will see in our next classes the other aspects of this chapter. So till then, take care, God bless you, all the best, and take care of yourself. Jai Shri Ram. Om